Hey everybody, welcome to the extension section for 10.3. In this section we'll be talking about how to choose appropriate measures. So in the last section we had looked at data sets and tried to determine if they were symmetrical or if they were skewed. And we're going to use that information now to get a little bit more specific with our data to see what exactly numbers can we put to our data. So for our key idea today, it talks about how to choose an appropriate measure. So it says the mean absolute deviation, which we learned from last chapter, uses the mean in its calculation. So when the data distribution is symmetric, if we want to find out a little bit more information about the data, we would use the mean and the MAD. So if it's symmetric, we use the mean to describe the center, and we use the MAD, or the mean absolute deviation, to describe how much our data varies. That's if we have symmetric data. If we don't have symmetric data, and we have data that is skewed, a good way to choose an appropriate measure would be to use the interquartile range to describe our data. And the reason is because it uses the median to find the center rather than the mean, and it uses the interquartile range to describe how our data varies rather than the mean absolute deviation. So if we're dealing with symmetric data, we're going to use the average and the MAD. If we're dealing with skewed data, we're going to use the median and the interquartile range, right? This is really important and probably something you're going to want to star because you'll probably have to look back at it. I know that I do. All right, so let's try one of those examples. It says the dot plot below shows the average number of hours students in class sleep each night. So we've got one person who sleeps 6 hours, another 6.5, another 7, and you can see that each dot represents one student and how much they sleep in a night, okay, the average. So the first thing we want to think about are what are the appropriate measures that we want to use to describe the center and the variation. Well, to do that, we have to think to ourselves, do I have symmetric data or do I have skewed data? Well, if I were to draw a line of best fit that kind of represents this graph, I see that it definitely doesn't look like it's symmetrical to me. It looks like I have a tail here, and most of my data revolves around this 9. So since I have the tail on the left, I'm going to say that it's skewed to the left. Okay, so I'm just going to put that reminder in here. It's skewed to the left. And so what would I use then to describe the center and the variation? Well, if it's skewed, I'm going to use the median and the interquartile range. So I'm going to say the median and the interquartile range. I'm going to abbreviate it. Okay. Because again, my data is skewed. And that's all I have to do for the first part. For the second part, then it wants me to describe the center and the variation. So in other words, find the median and find the interquartile range. All right, I'm going to list my data first. I always like to do that from least to greatest. So 6, 6.5, 7, I have 2 7.5s, I have 2 8s, I have 3 8.5s, I have 1, 2, 3, 4, 5 9s, 1, 2, 3, 4, 5, 3 9.5s, and 1 10. Whew, a lot of data there. So the first thing I want to do to find the center, I'm looking for the median here because I have skewed data. So I'll just underline to kind of keep track of my way that I'm finding my way toward the middle. And again, when you're finding the median, you're finding the middle number. So I like to just work my way towards the middle by underlining or crossing out a small and a big each time. And it looks like my middle number is 8.5. So the median is 8.5. And then I need to go ahead and find my interquartile range. So remember, when I'm finding interquartile range, that I'm finding the ends of my two boxes, the difference between those two, if I were to plot that in a box and whisker plot. So I need to find the median of my first half of my data and the median of my second half of my data. So I'm going to do the same thing. 9 and 10, 9 and 9.5. Again, I'm just working my way towards the middle point. And it looks like 9 is the median of the second half of my data. And the median of the first half of my data, working my way towards the middle, is 7.5. So to find the interquartile range, I subtract 9 minus 7.5, and that will give me 1.5. And let's not forget about our labels here. We're talking about hours. I'll label that other one too. So the median number of hours is 8.5 hours. It'd be a good way to describe this set of data, the middle point of this data. And the interquartile range is 1.5 hours. So the range is in your box and whisker plot, and that 50% of our data revolves around that point, those 2 points in our box. So that's a good data set, I believe. 8.5 hours of sleep. That's healthy. So hopefully you're getting around there for your average sleep in the night. In the next example, it says the frequency table here shows the number of states that border each state in the United States. All right, so we have bordering states and then how many times that happens. So first it wants us to display the data in a histogram. All right, so remember, histogram just uses frequencies and intervals. I'll also include a title. And in my title here, I will say we're talking about the number of bordering states for each state in the U.S. So an example of that would be like how many states border, let's just take Wisconsin, for example. Okay, looks like I got Minnesota, Iowa, Illinois, Indiana, and Michigan. So 1, 2, 3, 4, 5 states border Wisconsin. Okay, so that would fall under this category. We have 4 to 5 bordering states, just like 21 other states. Okay, so here we'll come down and we'll put our number of bordering states. And then, like usual, we'll put our frequency on the left. So for my numbers here, I go from 2 to 22. So I'll just go by 5s, maybe 5, 10, 15, 20, 25. And then for my bordering states, I have 0 to 1, 2 to 3, 4 to 5, 6 to 7, and 8 to 9. I guess I didn't need to make it quite so big here. And how many times? Let's see. So from 0 to 1, this interval is 3. 2 to 3 bordering states, 13. Here. 4 to 5 bordering states, 22. That looks by far to be the most. 6 to 7, we have 10. Whoops. Don't erase on me. 10 for 6 to 7. And then 8 to 9, we have 2. All right, and there is my histogram. Letter B says, what are the most appropriate measures to describe the center and the variation? So again, for this, when we're looking at the appropriate measures, we need to think to ourselves, is our data symmetrical or skewed? And if I look at this data, it follows a really nice pattern. It almost looks like it's an exact mirror of each other. It's not quite, but it's really close. It follows that nice bell shape. So we have symmetrical data. And when we have symmetrical data, we're going to use the mean and the mean absolute deviation to specifically describe our data. And that's all it wants. It doesn't even ask us to find the median or the MAD. We just need to say those are the two that we would use to describe the center and the variation because we have symmetrical data. Right? That does it. That's the extension for you. It's just a couple examples. The next thing you'll need to do is the practice on page 457. So let me know if you have more questions. And that concludes this video. I'll see you next time.